Mr. McNabb?
How you doing? Rob McNabb, Northshore Technical Community College. I don't have any lunch on my face, do I? You all would tell me, right? You'd tell me? Yeah. Okay, all right. Want to make sure.
Who's the guy up there on the screen first?
This is my twin brother, James.
He works for LCCC, doesn't he?
I'm the HVAC instructor at Northshore Technical Community College in Hammond, Louisiana. And what I'm going to cover is how we got where we are right now from where we were a year ago. I have posted a simple lesson plan on the shared drive that covers the first lesson that I developed. I say I like I did it, but it was actually my students developed on the initial attempt for us to operate donated equipment that was given to us by a company called Computrols. It was necessary for us to get equipment. We do still use Sedona, but we don't have an actual controller anymore because a student moved a wire on ours, and it made some weird noises and then stopped working. Our first use of that controller was by putting it onto a block of wood and then running it off the laptop and doing the same experiment that Bob Clark had put together 3 years ago about emulating a room thermostat. And that was used to introduce students to the logic, the object-based logic that is available in Sedona, and also introduce them to how to wire up an input and output device. It was very basic. We had no curriculum. We couldn't develop any new curriculum because we were under the strenuous rigor of applying for accreditation through a new accrediting body, so we couldn't really develop any new curriculum. So this was incorporated into a class that was based on residential controls. As we got our accreditation, we developed our electrical trainer, and this trainer was designed to grow with the students as they progress through the program. So it's a NEMA cabinet trainer, and what it does is it gets the students used to the idea from the very beginning how to properly wire a commercial cabinet. In this trainer, it's already got factory wiring installed in it, and then the students use terminal boards to insert a basic DC series circuit with resistance, then a basic series circuit with lights, basic series circuit with actual controls, and then they learn relay logic in there, where they learn what an AND circuit does and what a NOR and NOT circuit do. But also their final big project when they're leading up to the commercial controls class is to have a memory circuit in there, where they have a momentarily closed three-way switch that will operate a light on the cabinet, and then when they release the switch and it's in the off position, the light remains on until it's cleared by an operation of another switch, which doesn't seem very complex, but it is complex to the beginner. On the front of the panel is numerous test points, and when they're wiring a circuit up, they wire up the test points so that when the panel's closed and the circuit's in operation, they can see the voltage drop across separate components without opening the cabinet. This actually turned out pretty nice, and some things have blown up inside the cabinet and not in front of the students. You miss the show, but you get to see the results. Once we loaded it as a BAS trainer, we replaced our enable switch that was in the middle there with a room sensor, and then we have different meters and indicator lights, and those indicator lights can have a different function depending on. And what we do is we take a little painter's tape, place it right under the switch, and write on what the function of that light is to simulate a load. In our lesson plan, we start out with the basics. How does it work? And their first objective is to install a piece of DDC equipment. And this lesson plan is incorporated in our commercial air conditioning controls course. They begin with relay logic and how to set up motor starters and so forth, but then we get into our DDC controls from relay logic. So the students first have to use a worksheet to familiarize themselves with the inputs and outputs of the controllers that they have in front of them. Then I check their worksheet and make sure they understand what they're looking at, that they're familiar. Okay, this is how I wire something in. This is what it's for. It'll have a nomenclature on it, like this one will say, all right, do they understand where my communication ports are? Do they understand what an input and an output is? What does it mean when something is a binary output? What does it mean when something's a universal output? They have to understand what they're going to be wiring into. They do that with both controllers, and then they commence to wiring it up. Before they wire it up, they develop their own wiring diagram. So what we have here is we have the factory wiring diagram of the trainer board, of what's the wiring they don't mess with. They have to neatly draw the wiring that they're going to put into the panel to make it work with whatever function scheme I have come up with for that exercise. So they have to, they use pencils, rulers, and whatnot to draw their wires. Where is each wire going to go? But they have a schematic to go by. We all know a schematic, which is function, doesn't necessarily relate to orientation in a cabinet, so they're going to look very different. And it kind of gets their minds oriented to how am I going to physically make what's on my functional flow diagram happen. When they do that, they have a better understanding of what they're going to do before they go into the lab. And it gets them, or like you have drawing changes they have to do that they have to do it neat. So they hand you a piece of paper and it looks like a 4-year-old drew something on crayon on it. You're like, I'm not taking this. Redo it. You've got rulers. It needs to be neat. Hand it in like you're handing it in to a supervisor to get something changed. Gives them a little bit of skill as far as presenting their ideas. Once they have an accepted wiring diagram, it's time to go to work. Here we have an example of one of those trainer boards, but it's been modified. And this is one on the end of the room, and this was modified to handle the host controller, or what we would call the master controller. There's only one master for the whole lab, and the rest of their zone controllers they wire, and they have to wire the communication wires, daisy chain style, MSTP network, all the way across the classroom wall. We have one VAV right now. I have a bunch that I've requested funds for. We'll see if I get them. But we at least have one operational one, and then the rest of the VAV controllers sit on a table so that they can observe them, and they operate lights off of it. This one that I use for the initial demonstration to the students, I have actual heater coils and contactors to initiate stage 1 heat electric, stage 2 reheat electric. And then in the other ones where you see the room sensor on the other ones, they'll have a light that initiates stage 1 heat, stage 2 heat. They both go off, and then it goes to cool mode depending on where their setting is on the thermostat. Here's a brief parts list. I won't go into it in detail, but the parts list is also on the lesson plan. And it's particular to using this type of equipment. Even though I'm using CompuTrol's equipment, you could use this for any platform. Use it for any type of platform that you have. And then it's time for those students to get to work and do the installment phase of the lesson. That equipment that they're installing is just equipment. It doesn't have any software on it. They're just bricks that they're putting in pretty much. So they get it all wired up, and they get everything configured, and now it's time to go back in the classroom, and we have to tell them, all right, this is what we want it to do. How do we come up with the logic of what it's going to do? How do we tell it what to do? And we get them into the idea of the logic thought process, and they have to come up with a flow chart of, well, first I have this, I need to check if this is it's in this condition, or if it's in that condition. If it's in that condition, then I have to go check in this. So they start developing logical flow charts so that, of the function that we're asking them to have it perform. When they get to that point, it's not a touch screen? Darn it. Huh? I got spoiled in my classroom. They spoiled me rotten. Here we go.
Go fast and late.
Let me see if it'll talk without my little insert here. The students have a touch board like this one in the classroom. And what they're able to do is they're able to navigate through the control software. And when it gets to the point where they choose the controller that they installed, it's on the software, but it is not on the hardware. They can open up the one that they are supposed to control, and all the points are already there. And then they come in and set up the logic. So I can say heat stage 1 logic. Once the student's in that logic, any parameters that are in there is a line item interface, but they don't type in there. You can't type in there. Any parameters that are loaded and any input-output devices that have been loaded into the software become a point that you can use a drop-down menu and build the logic from those points that you've loaded. They can be software points like a schedule. They can be hardware points like a sensor. They can be hardware output points that are analog and digital. So you can come up with logic that they use the drop-down arrow and they choose if, and they use a drop-down arrow, VAV2 box mode. I can click that, and then it gives me a choice. Is in what mode? Cool, heat? If it's in heat, and then I have a line of logic there. Then it gives them another line, and it says, do you want another statement? Yes, I want to put an and in there. And then they use the drop-down. If the VAV2, they choose that, then they choose occupied, unoccupied. They just choose these from drop-down menus. And they end up with this piece of logic. And then they save it, and then they go on to the next one. When they get all of this loaded, I'm trying to touch the screen. You all see me trying to reach for that screen? I got so spoiled on my... When they reach...
In my classroom, I've got a touch screen. This is construction's area. Don't.
That's all right, that's all right.
We're judging you.
I'll survive. I'll survive. Once they get all that done, it's time to load it onto the components. So this actually, we've done this twice so far, and both times, I don't know if the students got as much of a kick out of it as I did, but I got the biggest kick out of it. They go in there, and all their thermostats that they have on the wall, they're blank. They have a red light on them, and there's no display. There's just communication lights on their VAVs, but no functions are happening. They have everything labeled, they have everything ready to go. This laptop right here gets plugged into the main controller, and it connects. And then I stand back, and then you start seeing displays come on the thermostats as their software gets loaded. Then lights start coming on and coming off on the cabinets. And then once everything's running, the students go through and do a functional test of the system by cycling through the set points on the thermostat and making sure they get the indications that they're supposed to get. It's the most important step. And once they finish that function test, then the project is complete. So, worked through it a couple of times. Of course, we've had our bumps in the road. Needs to be a little bit organized, but it's something right now, and so I'm rolling with that for other projects. But that's what we've ended up with, and that's the end result of last year's workshop. And so we end up with this lesson. So I think I used up all my time, but I hopefully have some time for some questions if you got them.
How long is the workshop?
What's that?
How long is the workshop?
Which one?
The one that you...
Oh, that's not a workshop. That's the result of our last workshop. This is the lesson. But the lesson itself, it usually takes about 2 to 3 days depending on what kind of group of students I have. Because I'll concentrate one day on how do I make my ladder logic or how do I make my flow chart. So we'll spend a day on logic. So if I want to put it into hours, I'd say it was about a 12-hour, but it's 6 hours per objective. And there's 2 objectives in the lesson. First objective, install. Second objective, setup.
What kind of classes is it?
This class is called is called Commercial Air Conditioning Controls, is the class.
Where does that class fit into the overall curriculum?
We have our overall curriculum. We have 3 different certificates: residential, commercial AC, and commercial refrigeration. And this particular course falls into the commercial AC certificate, which if they take the core courses, they can get a credit diploma for, or an Associates of Applied Science in HVAC with a concentration in commercial.
How many prerequisite courses to get to this course?
This one, they'll have to have basic electricity, electrical components, motors, advanced AC, and troubleshooting. And that's their core courses. And then they have to take the first commercial AC course, which is commercial AC 1. Then they can take commercial AC controls. So they have quite a buildup before they get to this point.
Yeah. And is this a capstone, or is there another class after this?
There is another class after this that's the capstone, and that's commercial AC 2. But they have to have this class before they get into commercial AC 2.
I haven't seen ground controls like that in a long time. On those right there. Oh, what generation is that?
That's their B generation, which they call B controls, but that software is loaded onto a prototype version C, which they haven't released yet.
It might have been like 8 or something. I purchased it.
This is their B, but it's loaded onto C's, which are not available on the market yet, but they donated the C controls, but loaded that software. The C controls are supposed to be Wi-Fi and Bluetooth capable, but I think they're running into security issues with that, and that's what's slowing that down. But we do have the prototypes in our lab. All right. Yes, sir.
Do you teach all that electrical yourself, or do you have an electrical department that you work with?
We have, for up to the case, up to the component, we have electrical program that has electrical students. They run all the conduit and everything. Inside the appliance or from the disconnect to the appliance, myself and my partner instructor, we teach that.
What I meant was in the core courses.
I teach it because we have a HVAC slant on it.
Can't trust those electric guys.
Those controls still give up their 3 graphics package?
Yes, they do. In fact, I've been messing with it.
When we get graphics.
And I've been messing with it too. It's pretty cool. Looks almost like the Zigo. Nobody else? Alrighty, thank you.